Algebra I 10.6b, Rational Equations and Extraneous Solutions. The word extraneous means unrelated, not connected, and irrelevant. Some rational equations may have extraneous solutions. When we solve the equation and it doesn't fit, when we check it, it's extraneous. When the solution makes the denominator of our rational equation equal to 0, it's extraneous. Denominators can't be 0. Rational expressions are fractions, aren't they? And fractions are little division problems. I always say that. We can't divide by 0, so if it says the denominator is going to be a 0, it's an extraneous solution. Take a look at this one. Here, look at this rational equation. We've got 4 over x plus 2 is equal to x squared over x plus 2. So we can see that the lowest common denominator is x plus 2 because they both have it, right? So we're going to multiply both sides by x plus 2. And when I'm dealing with rational expressions, because they look like fractions, I like to put it over a 1 so that it's easier on my eyes and I can multiply the numerators and then multiply the denominator. See? So we multiply both sides by x plus 2 over 1, and we get 4 times x plus 2 over x squared times x plus 2, and that's going to be over x plus 2 on this side and over x plus 2 on this side. See? Can you see where we can cancel out? Yeah. This x plus 2 over this x plus 2 can cancel out, and this x plus 2 over this x plus 2 can cancel out, and the only thing we're left with is 4 is equal to x squared. Well, x squared really means x times x, doesn't it? So that means we have 2 times x, so 2x. Now, all we have to do to isolate the x is to divide both sides by this coefficient 2, can't we? That's identity property, our friend the invisible 1. So 4 divided by 2 is 2. We end up with 2 is equal to x. Now remember, negative 2 times negative 2 can also be a positive 4, can't it? So we can actually say that it's negative 2x to be a positive 4. And to move the negative to the other side, because our friend the invisible 1 is there, we can just divide both sides. Once this becomes a negative x, we can divide both sides by a negative 1. Negative 1 divided by negative 1 is a positive 1, so now we have a positive x. But because we divided this side by the negative 1, we have a negative 2, so that way we moved that negative to the other side. You can also just do it in your head if you want to. If it says negative x equals 2, you can just say x equals negative 2. You can just flip it over, okay? So now when we check it, we're going to try putting 2 in and negative 2 in to see if it works. So putting in a 2 wherever there's an x, we get 4 over 2 plus 2. And we get 2 times 2 over 2 plus 2. Well, that gives us 4 over 4 on this side and 4 over 4 on that side. That's a 1 and a 1. So yeah, that checked out. That worked. When we use the negative, we get 4 over negative 2 plus 2. Well, that's 4 over 0. And negative 2 times negative 2 is a positive 4 over a 0. And we can't have 0 as a denominator. So this negative 2 answer is extraneous. See? This is the extraneous one. So this one is good, but not this one. Okay? That's the extraneous answer. It's the one that's not relevant. It's not connected. It won't work. It's unrelated. Okay? So when solving equations with rational expressions, reject any solution that makes the denominator equal 0. Okay? Because it's extraneous. All right? And, of course, remember that you can always write them over 1 so that they'll be in a fraction form. Okay? That might make it easier on you. Our next video is going to be 10.7a. We're going to talk about using rational equations to actually solve some problems. And if you want to go back and watch any of the previous videos like factoring, or we talked about the principle of zero products in the last video, okay, or unlike denominators or like denominators, if you want to see any of these, there'll be links in the description of this playlist, of this video, okay? Okay, we're going to move on. We're getting close to the end of chapter 10. Thank goodness. I'll see you next video. Bye.